For today's lesson, we're going to be talking about polynomial inequalities. This will be very similar to what we did with quadratic inequalities. So let's review those real quick. This first one we know is quadratic because that's the highest degree that we have. And then when we were solving a quadratic equation, we always needed it equal to 0. So that's what I'm going to start with. I'm going to get the inequality equal to 0 by moving the 15 over. So I subtract 15, now it's less than 0. And then we look to try to factor it. This one, we could factor our 2x squared into 2x times 2x, or sorry, 2x times 1x. And then we find our factors of 15. So this would work if this was a 5 and 3, because I need a negative 1x. And so the outside gives me a 6x. And if I had a negative 6x and a positive 5x, that would combine to give me a negative 1x. So this is factored all the way. We then took each factor and found our zeros. So 2x plus 5 equals 0, which will end up giving us a negative 5/2. And then x minus 3 equals 0, and x equals 3. The main thing that we want to pay attention to is that those are not the solutions to this inequality. An inequality is a range of values. So we want to take those zeros and put them on a number line. Now negative 5/2 would come first because it's negative, then positive 3. And we're looking at when it's less than 0. So I just put that off to the side to remind us what we're trying to find. It's less than, which means it doesn't have the equal to, so these are open circles at negative 5/2 and positive 3. When we were doing quadratic inequalities, we had two methods that we could do. We could think of this graphically, or we could do a sign analysis and do our test intervals. With polynomial inequalities, you can do it the same way, but I think graphically actually ends up being a little bit harder because we could have cubic polynomials or 4th degree, 5th degree. It just depends on what degree polynomial we have. So what I'm going to do is just review the test interval method. So we set up the 3 different areas and we did sign analysis on each interval. So we want to pick a value to the left in between negative infinity and negative 5/2. And so that could be something like negative 3. So let's do that in a different color. So let's pick negative 3. And we just test it out. And I can just go straight to our factored form and do 2 times negative 3 plus 5. And then negative 3 minus 3. We're wanting to know, is that going to be less than 0? And if I test it out, that's negative 6 plus 5. Negative 6 plus 5 is a negative. Negative 3 minus 3 is a negative. So we get negative times a negative, which ends up being a positive. Remember, we're not really trying to find the exact value that comes out when we evaluate it. We're really just looking for the sign. That's why it's called sign analysis. I'll just write that out, sign analysis. So this left side is going to be a positive. Then we pick a number in the middle. An easy one to pick is 0. And I can plug 0 in. When I do that, that'd be 2 times 0 plus 5, which is positive, and 0 minus 3, which is negative. A positive times a negative is negative. And then we pick a value to the right of 3, so 4. And we plug that in. 2 times 4 is 8. 8 plus 5 is still positive. 4 minus 3 is still positive. And then positive times a positive is positive. So our sign analysis shows that the only area that is below 0 is that middle section. So that's our solution region, and we just write our solution in interval notation. So it should be parentheses negative 5/2 all the way to 3. Okay. So for number 2, it's still a quadratic. Why don't you go ahead and pause the video and just try out that sign analysis method for number 2. Okay, so if you've already solved it out, what you did was you factored that quadratic into 3x times x, and then we need factors of 20, so 5 and 4. They needed to combine to give me a positive 7, so positive 4 and negative 5 would end up working. That gives us our two zeros of 5/3 and negative 4. We take each of those and put them on a number line. Negative 4 would come first, and then 5/3. We want the values that are greater than or equal to 0. Since it has the equal to, that means we can close in those circles, and these values are included. We work out our sign analysis by testing out each interval. So I could pick a number to the left. Let's pick -5. So if I plug -5 in, that'd be -15 minus 5, which is still negative. -5 plus 4 is negative, and a negative times a negative is a positive. We test out a value in between, like 0. 3 times 0 minus 5 is just -5, so that's negative. 0 plus 4 is positive, and a negative times a positive is a negative. Lastly, we pick a value to the right of 5/2, so this could be something like 2, or 3, 4, 5, anything bigger. So if I plugged in 2, I get 6 minus 5, which is still positive, and 2 plus 4 is 6, so that's still positive. And a positive times a positive is positive. So we are looking at when this was greater than or equal to 0. We already found the equal to sections. So the graders are going to be these positive values. And that's going to be off to the sides here. So our solution region would be -infinity all the way to -4 with a bracket, since it's got the equal to, it's included, union, bracket, 5/3, all the way to infinity. Now remember, you could have solved that graphically, and you would think about what direction your quadratic is opening, but when you get to a polynomial, you have to think about the degree, the leading coefficient, and what that does to the end behavior as well. So there's a little bit more to deal with than just a parabola. Now, if the polynomial is already factored, then you can easily find our zeros and do your sign analysis on the number line. All right, we don't want to multiply out that type of problem because we're looking for something in factored form anyway. So this is actually a lot easier and quicker for us. What we would do is find each of our zeros, which ends up being x equals +4, x equals -3, and x equals 1. So we take each of those zeros and put them on a number line. Now we want to go in order, so -3, then 1, and then 4. We're looking at when it's strictly greater than 0, which means those are all going to be open circles. We have 4 different test intervals to do based off of this. So I'm going to set up our intervals, and you can plug in a value in each interval. So I'm going to try -4. You're plugging this into every single one of these factors. So let me show my work just for that first one at least. But -4 minus 4 times -4 plus 3 times -4 minus 1. That would be a negative times a negative times a negative. And a negative times a negative times a negative total is still negative. So we know that this section to the left is always going to be a negative value. Then we pick a value in between -3 and 1. A nice one would be 0 in that area, but we could have picked -2, -1, any of those values. So if I plugged in 0, that would have been 0 minus 4 0 plus 3, and 0 minus 1. Well, 0 minus 4 is negative, 0 plus 3 is positive, and 0 minus 1 is negative. So we get a negative times a positive times a negative. Well, negative times a negative is already positive, and positive times a positive is positive. So this section is going to end up being positive. All right, the section between 1 and 4, we could have picked something like 2. If I plug 2 in, I get 2 minus 4 is negative. 2 plus 3 is positive. 2 minus 1 is still positive. So a negative times a positive is negative. And then lastly, pick a value to the right of 4, like 5. And we test it out. So 5 minus 4 is positive. 5 plus 3 is positive. 5 minus 1 is still positive. All that multiplied together is going to still give me a positive value. So we then just decide what sections do we need to include. And we want the values that are greater than 0. Those are all those positive areas. So it's looking like this shaded part. We write that in our solution inequality. So I take that solution and do parentheses -3 to 1 union 4 to infinity. You do want to make sure you're paying attention to if it was an open or closed circle based off of the inequality symbol that we were given. Okay. Now number 4 looks very similar. It's in factored form already, but we have a multiplicity, and that's okay. It's still going to work based off of our sign analysis. So this gives me an x equals 3 and an x equals -5 for the zeros. When I do this on my number line, oops, -5 comes first, and then 3. But there's not another number for me to pick because 3 was our multiplicity, and that's okay. It's still going to look for when it's greater than 0, which means these are open circles. Pick a value to the left of -5, so -6 would work. The biggest thing here is you have to still consider that square. So if you plugged -6 in, what you're doing is -6 minus 3 squared, then -6 plus 5. So while this does come out negative, -6 minus 3, you're doing a negative squared, and then -6 plus 5 is still negative. Well, a negative squared, or any value squared, is always going to come out positive. So we end up with a positive times a negative, which is negative. So just make sure you're paying attention to your multiplicities. And then I pick a value in between -5 and 3. That could be 0. So 0 minus 3 is going to be negative, but it's still squared. And then 0 plus 5 is positive. Negative squared is a positive, and a positive times a positive is positive. All right, and then lastly, pick a value to the right of 3, like 4. So we plug that in. 4 minus 3 is positive, it's squared, and then 4 plus 5 is still positive. So we get a positive squared, which is just positive, times a positive maintains a positive. All right, now all these values that are greater than 0, we're going to shade in. So that's the area in between -5 and 3. And then also after 3. So this solution region would look like parentheses -5 all the way to 3 union 3 to infinity. Now I do want to at least discuss if that had been a greater than or equal to. So let's just slightly change the problem and say I wanted greater than or equal to 0. All that would do is close in those values at -5 and 3. So this is a what if. It had been greater than or equal to 0. We get the closed circles. It would still come out negative, positive, positive. So all of the ones in between -5 and 3, 3 to infinity. When you're looking at something like this, it does not need to be broken up into two sections. It doesn't need to be broken because this is still continuing on. We're going from -5 and still going through 3. We're not jumping over 3. So it would say bracket -5 all the way to infinity. So just pay attention to what that inequality symbol is. For our last one, we have something that's not in factored form, and we've got actually a lot of stuff to work out. So what we need to do is a little bit of algebra, and I see this thing squared first. So I'm going to take that -3x and just leave it the way it is. But x minus 2 squared would be x squared minus 4x plus 4. And then we still have plus 9 outside. We distribute our -2 to x squared, that'd be -2x squared. And then positive -2 times -14 is 28. Minus 19x. All right, we take that and put a piece of paper underneath here. All right, so I want to get everything combined like terms. So I'm going to take that x squared and then combine -3 and -4, so it's -7x. A positive 4 and positive 9 is 13. -2x squared, -19x, and positive 28. We just put that in standard form. I still need everything on one side, and I like it where the x squared is positive, so I'm going to move this to the other side so that it is going to be a positive x squared. That means I also need to move the 19x and the 28, so minus 28. Okay, let's see. That should give us 3x squared, a -7 and 19 would be positive 12x, and then -28 and positive 13 is -15. So when I look at that, there's something I noticed, that there's a GCF between all three of those, because 3 can divide into 3, 12, and 15. If you didn't recognize that, that's okay. You could still factor it, but it would be a lot easier if I factor out the GCF. So take out that, I get x squared plus 4x minus 5. And then that's nicer to factor, so that would be 3 times x plus 5 times x minus 1. We find our zeros, we get x equals -5 and x equals positive 1. We start this the same way we have been doing. So -5 comes first, positive 1, and I need open circles. If I do my sign analysis, I pick a value to the left of -5, like -6. When you do this, you still need to consider what was that greatest common factor, because if that had been negative, that's going to impact our sign analysis as well. So it's really 3 times -6 plus 5 times -6 minus 1. When you do that, 3 is a positive, -6 plus 5 is a negative, and -6 minus 1 is a negative. So you get, and positive times a positive, which is positive. So then we go to our numbers between -5 and 1. I'm going to choose 0, it's usually the easiest. That'll be 3 times 0 plus 5, which is a positive. 0 minus 1 is a negative. So that's really a positive times a positive times a negative, which ends up being negative. Lastly, pick a number to the right of 1, so maybe 2. and 3 times 2 plus 5 is positive. 2 minus 1 is still positive, so I get a whole positive. So all the values that are less than 0 are in the middle. So our solution should say -5 to 1. All right, so go ahead and try the rest of these that are in the lab manual.